Let us have it.
Okay, AP students, here we go, Chapter 4, Acid-Base Chemistry. Okay, now normally you would be here doing this live, of course, but you're going to have to watch us plow through this and try to observe what's going on. We'll do our best to try to explain everything. So because last spring was so disrupted, you probably never had a chance to do a process called titration and to use a device called a burette. Okay, it's a very, very standard technique in any chemistry lab. And so what I always point out to people is if you have a dry sample, you can put it on the scale. I can get the mass. I can change mass to I can change the mass to moles. I can calculate anything I want. But if something's dissolved in water, then it's got to be a different process. And so if you're starting to learn, if I know the molarity of a solution and I can measure the volume, if I multiply molarity and volume together, I know moles. Once I know moles, I can calculate anything you want. So my point is this burette is the counterpoint to an electronic balance because it reads volume very accurately. Okay? And if you look at the graduations here, it's graduated from 0 at the top down to 50 milliliters at the bottom. In other words, it reads top down.
Wait a minute, they must have made a mistake when they made this thing, right? 0 at the top?
Chemists never make mistakes.
Wait, oh, that's true.
Yeah, no, it's perfect, of course. So it reads top down, so we can run successive trials and see the increment in volume that we're using. And it's graduated in 1/10 of a milliliter increments.
Oh, yeah.
Okay, do we need the background to see that? I don't know how well you can see that. It's marked off in 1/10 of a milliliter, which means we can estimate
To the hundredths.
to the hundredths place. So
It's
we
having trouble focusing now. Just a few minutes ago, it was focusing fine.
Really?
Yeah, I can't get a nice sharp.
Is it background somehow?
No, your background is helpful because
Hmm.
we can't really see the lines. Gosh, is that? We're gonna have to figure this out. Because if you can't see the bottom of the meniscus and where the line is.
Yeah, that's bad.
Maybe if I stand back here and zoom in. Oh, there it is. Okay, so yeah, right now we have 0.00 for the volume.
In other words, the burette's telling you the volume that you've used
Mhm.
because it reads top down.
Yep.
Okay, so if I know the molarity of what's in the burette and the burette itself reads the volume accurately, in other words, we can measure out moles
Mm-hmm.
with a burette, which is very handy. Okay?
Yep.
And there's a valve at the bottom that you can turn, in fine degrees. And so you can get the fluid to come out the bottom as drips. So you can add fluid quickly or very slowly. It's a very accurate way to measure volume. You may want to put one of these on your birthday list. I know I got one when I was probably 5.
Nice, yeah. I keep asking every year. I don't get one.
Yeah, for sure. Okay, so now the next thing is this. This lab involves a titration using some sodium hydroxide base that's going to be in the burette, and we're going to titrate then some unknown acid samples. But we can only make this useful if we know the molarity of the base that is in this burette. Because I want to be able to go molarity times volume in liters to get moles. And a very common base to use is sodium hydroxide. Strong base, 100% ionization, which is great. It's very water soluble, which is great. It's not very expensive, which is great. It's got a lot of things going for it, but there is one downside. It's hygroscopic,
Mm-hmm.
which means when it sits out in the air, it absorbs water from the air. So if I say to you, hey, I'd like you to make a 1.00 molar solution of sodium hydroxide, and I'd like to have 1 liter of this, you would say, well, okay, I need 1 mole of sodium hydroxide in that 1 liter.
Mhm.
I'm going to need 40 grams of NaOH because that's its molar mass. So now you're sitting there weighing the NaOH out in your balance, but the problem is it's absorbing moisture from the air while you're doing that. You can actually see the flakes of NaOH get shiny because they're getting wet, absorbing moisture. It'd be especially bad like on a really humid August day. There's a lot of water vapor in the air. So my point is, you can't get an accurate mass measurement. So you'll say, boy, I want to measure out exactly 40.00 grams of NaOH. And you dump that on and the balance reads 40.00, except some of that's water. You don't really have 40 grams of NaOH. So, in order to get an accurate molarity for our NaOH, we have to do a process called standardization. Okay, we're going to standardize the base and figure out what is its exact molarity. Okay? How am I doing, Mr. Moore?
Yeah, that sounds right. That was great.
Just yell if I...
Yep. Now, how are we going to standardize? Standardizing is trying to determine what is the concentration of the sodium hydroxide in that burette.
So what we're doing
yeah.
then is we're using a primary standard acid to help with this. And the one we're using is potassium hydrogen phthalate, KHP for short. Okay? Now, when you say KHP, there's Mr. House. Mr. House loves to learn chemistry.
Mr.
Where
House,
are ya?
hello, just in time for a chemistry experiment.
Remember to wash your hands.
Right.
Have a great weekend.
The healthy
everybody.
ambassador. Thank you, Mr. House.
See you guys.
See ya.
Okay, see you.
So anyways, when we say a KHP, do not think the P is phosphorus.
Mm-hmm.
It's this organic molecule known as phthalate, KHP. But we know the molar mass, I don't know if we can see it, is 204.2.
Yep.
So the deal is we're going to weigh out accurately a mass of KHP. Because we know its molar mass, we can figure out how many moles of KHP are here. We can titrate with our NaOH that has an unknown concentration, and we'll be able to figure out the molarity of our NaOH. Now, built into this is something called the end point. Okay? So, as we're titrating, I have to know when to stop adding the NaOH so the moles of base equal the moles of acid.
Right.
And that's called the end point. We're using an indicator called phenolphthalein to help us with that. So you'll see this in a minute. Phenolphthalein is colorless in an acid, but it turns pink in a base. And it's going to mark the end point for us so we know when to stop titrating.
So the end point is the point at which both reactants get used up at that same time. There's
Right.
no excess or limiting. They just both run out at the same time.
Exactly. We know at that point we have exactly the same moles of acid and
Mhm.
base.
Mm-hmm.
And so, if I know the moles of acid, which I do because I measured its mass,
Mm-hmm.
and I know its molar mass,
Yep.
I then know how many moles of base were there, equal to the acid moles. The burette's going to read the volume for us very accurately. So I can go moles over volume, and I'll have the molarity
Get the
of the
molarity.
base.
Hey, that's pretty good.
Yeah, that's called standardizing the base.
Mm-hmm. Not dropping the base.
Not dropping the base,
Okay,
standardizing
okay.
the base. Okay. All right, so
So let's get at it. We have some pre-measured KHP samples, right?
we do.
So we'll need this mass of KHP so that we can tell how many moles are there.
Yeah. So here we go. Here's our first sample.
Okay, we have a mass.
Okay. Now we're going to dissolve it into some DI water, deionized water. You could think of it as purified water. the exact amount of water that we use here makes no difference.
Mhm.
We're just trying to dissolve it so it's available to react with the NaOH.
Yeah, we know there's no point at which we need the concentration of KHP. It's just the number of moles, which we know from the mass of it.
Yep. So you do have to be a little patient. It does take a minute to dissolve. And of course, I can't see anything without my glasses on. So right now I'm looking, I don't know if it's dissolved or not. Mr. Moore has better than perfect vision. I think I still see some.
There is still some in there, yep.
Now, normally what happens, if we were in a chemistry lab at a university, they would tell you to run titration trials until you had 3 trials that agreed exactly. Trust me, that could be a lot of trials. I've been there. Have you, Mr. Moore?
Oh, yes.
Titrating, go, oh, I got to do another one.
Yep.
Well, we don't have necessarily the time for that. Certainly if you were here in class, we couldn't do that. So usually what we do is we've developed our own little system. We do 1 trial fast and sloppy, we call it, to get a ballpark idea, and then we try to run at least 1 or 2 more careful trials. I don't know, Mr.
So that
Moore,
must
can
be
you see?
dissolved by now, just based on the amount of time that we took. Anybody see any in there? I think that's,
Yeah, I'd have to
That's
put my
all dissolved.
glasses on to know for sure.
okay. We'll save you that trouble.
Okay.
It's dissolved.
All right, so we got the KHP, our acid. Here comes our indicator.
Yeah, let's not forget the indicator,
Yeah,
because
that's
if you
bad.
forget the indicator, then you don't know when you hit the end
Yep.
point.
I always tell people use 1 drop, 2 if you're feeling wild and crazy.
Right.
It's a Friday.
You can
We're-
see Mr. Hevel, yeah.
Okay, now we're going to start to titrate.
Yeah, sometimes people will put a white sheet of paper down there underneath that too, so you can see the
Yep.
pink.
Do you want to do that? Should I do that?
If it's handy.
I gotta clean
Oh,
this.
there's some of those
Oh, yeah.
scrap weighing papers.
Okay. Remember the phenolphthalein colorless and an acid, pink in the base. Now this is my fast and sloppy trial.
Okay.
I know the burette's at 0.00, my start point. And I'm just going to open the valve, run it fast. It's important to swirl while you're doing this. Okay, and you can see there's some pink as soon as the base hits there.
Oh yeah, I see
Right.
it. So how are you working this burette? Just so everybody sees it. That valve, what do you do? You just give it a twist, right?
Yep, it's closed if it's perpendicular.
Mhm.
It's wide open if it's parallel with the tip down there.
Yep.
And then, you can turn it however far you want.
You
see
see pink
the
show
pink?
up, and then it goes away. We swirl it away. We still have an oh well.
There
I was
we
going to
go.
say we have an excess of acid, but no longer. Phenolphthalein is pink when it's in a base, and so we have just taken this KHP acid and made it a basic solution with an excess of sodium hydroxide.
And I wasn't being very careful, so I know I went past the end point.
Mhm.
But now we have a ballpark idea of how much base it takes.
Okay, I'm going to zoom in on that. So don't subtract from 50. I know that you're going to be tempted to say, well, we need to know how much liquid is in the burette.
Mhm.
Just read it. It's between 3 and 4. I'll move this over a little bit so you can see what the graduations are.
Does it help if I put it right tight to it?
Yeah, we can see it pretty well. Okay, so try to go to the hundredths place. And now this will be the initial volume for our second trial.
Right. And of course, probably the best thing to do here is create a data table.
Mm-hmm.
Okay, so I'm just going to dump this out. Give it a couple rinses. Again, I don't have to worry about drying it out. The amount of water doesn't matter at all.
Mm-hmm. Which
And,
is very handy.
We'll move on to our second trial. Okay, so let me zero out this piece of paper. here's our second KHP trial.
Okay, there's our massive KHP.
Okay. Like before, into the DI water.
So will we want to use that first trial in our calculation of the concentration of the sodium hydroxide?
Well, it was fast and sloppy.
Yeah.
I think it has to be in our data because we did record a measurement, but personally, I wouldn't use it, I don't think, in my final.
So what are we looking for? How do we know when we're at the end point? If that was sloppy, what are we going to try to do now?
Right, so now we're going to try to catch the drop that turns this a light pink and keeps it pink.
Mhm.
And once I hit that point again, I know moles of acid here, which I can calculate, are equal to the moles that I've added from my burette. I'm trying to make sure we don't have any stuck to the sides here. Okay, Mr. Moore, your eyes are better than mine.
Just keep swirling a little bit
A
more.
little
in there.
more?
Yeah.
Okay.
Yeah, KHP is a little bit stubborn. This is
That's right.
a bit frustrating when we're doing this. You want to just swirl and go, but it takes a little bit extra time.
Always remember, the careful chemist is the happy chemist. Right? We have plenty of corny sayings. I'm sure you're happy you're not being subjected to it, though. Okay. Am I doing any better?
I see no solid in there. That's good.
Okay. All right. 1 drop, 2 drops. And here we go. Now, what was this again, Mr. Moore? This is somewhere between 3
It was, yeah,
and 4.
the low threes.
Yeah. Okay, so I know I can probably run in like 2.5 milliliters without having to be
Yep.
too careful. Really, I'm having trouble with AC, so I can run it in down certainly to 5
Mhm.
or 5.5 without too much worry. If I could see it, it would be helpful.
Yeah, because it was not exactly the same amount of KHP between the
Yeah,
first and
that's
second trial,
true,
but it was
too.
close.
That's true.
Yeah, when we know we're close to the end point, because that pink hangs around for a
Yeah,
while before it
longer.
swirls away, then we literally go drop by drop. And see, and we can control that with how much we turn that valve. Oh, looks like we're close.
Oh, that's super close. Okay, no pressure, but I'm trying to get one drop.
One more
here.
drop in there.
Ah.
Okay, maybe this is it. No? You got it.
Okay.
It's staying pink.
Yeah.
That one drop turned it over from clear to pink.
Yeah, that's called the
Okay.
end point.
Very nice trial. And okay, so yeah, we can see that it's very close to the 6. If I move it over, ooh, 5 point something. Read that. Okay, one more trial.
Okay. All right. Oops. All right, so there we go. One last KHP trial.
So yeah, a mass of KHP is not the same every time, so what we'll have to do is determine the molarity each trial and then take the average, each good trial. So again, that first trial, we don't need to calculate a molarity because we did not get a good endpoint.
Right. The best part is watching students titrate for the first time. And, you know, a group would be titrating, Mr. Hubble, it's not changing color. And they ran like the entire burette of base in. And I walk over, I put in 1 drop of phenolphthalein, and it turns flaming pink because they forgot to put in the phenolphthalein.
Yeah.
It's always good for a laugh. We really do miss having you guys here, really.
This lab teaches us to be patient and gracious with our lab partners too.
That's right.
Because when it comes down to that last drop, sometimes it's a splash instead
Yeah.
of a drop, and
That's right.
that's good for a laugh from the front of the room,
It is.
isn't it?
Okay, Mr. Moore, I'll ask you again.
I think you got it that
Got
time.
it?
I don't see
Okay.
any solid in there.
All right. Okay. Here we go. All right, remember that last burette reading becomes the initial burette reading now.
Yep.
Is that powder stuck to the side here? Or is that just water drops?
I see just water drops.
Okay.
I don't see any powder.
Without my glasses on, I can't tell. Okay. We're at just about 6, so I should be able to go down to 8 for sure.
Mm-hmm.
I would think. The swirling part's important, right? Because you got to get those reactants to mix together. Oops.
Yeah, we're working together. Normally, one person is running the valve on the burette, the other person is swirling. Mr. Hevel is a professional.
Yeah.
He can do it all himself.
Right. I think we're pretty close. Come on, one more drop. Oh,
He
gotta
wants
be
more.
close.
That's it.
I call this the chemistry coordination test. If you're able to run the burette and swirl at the same time. It's kind of like tapping your head and rubbing your belly.
Yeah, you can forget it.
Right.
Forget it from me. Okay, there it is. You got that?
Okay, so remember, the goal here is to standardize the base. You're trying to determine the molarity of the NaOH that's in this burette. Once we know that, then we can use this NaOH solution to titrate an unknown acid solution that's going to be the second part of the lab.